Hello students, program 10 is GAUSS elimination method. This is a method which is used to find solutions for simultaneous linear equations. So, simultaneous linear equations is an equation where we contain more than one equation and we have more than one variables. So here the solution will be the to find the unknown variables. So based on the equations we'll be giving, the solutions will be there. And coming to the coding part, here we have including one header files, that is stdio.h, and in the main program we are declaring the variables I, j, k, n using a int data type, and then we are declaring a matrix A of 20 into 20, C x of 10, sum is equal to 0.0 using a double data type. So the simultaneous linear equations, what the question will be there, that the coefficients of that equations are given as the input to the problem. So here it is in the matrix form. So matrix form, in the sense we have to give the input first, the order of the matrix, and then we'll be entering the coefficients of the equation of all the equations as the elements of the augmented matrix in a row wise. So here we'll be giving the input, that is the order of the matrix, and then we'll be entering the elements of the matrix in the augmented matrix row wise. So as we all know, when it comes to our matrix, it is a two-dimensional matrix. So here we'll be using two for loop, that is for I is equal to 1, I less than or equal to n, I plus plus. It when this condition gets true, it get inside the loop. First I is initialized to 1 and it will check with the condition. If condition get true, it will get inside the loop where it will check for j is equal to 1 and the condition j is less than or equal to n plus 1. If it is true, again it get inside the loop. It will read the elements and come out, j is incremented, and it process will get on till the condition get false. When the condition get false, I is incremented and then it will check with the condition. This process will go on until and unless these two conditions is this condition is get false. So after it come out of the loop, all the elements of the matrix is scanned. After this, so this is a set of statements which is used to enter the elements of the augmented matrix row wise. And in Gauss elimination method we have two steps. First step is triangularization, that is we have to make lower triangle elements or upper triangle elements 0, and the another step is backward substitution. So here we can see a set of statements. Here we can see a set of statements which is used for triangularization. So this is, again we are using a for loop to traverse each and every element of the array, the matrix, and so the for loop, and for j is equal to 1, j less than or equal to n, j plus plus, it get inside the loop and it will check for I is equal to 1, I less than or equal to n, and it will get inside the loop. So here you can see if I is greater than j. So here it is, if I is greater than j, then all the statements will be executed. So all the statements get executed. If not, it come out of the loop. So here it will go for the second row first element and it will see for this. Okay, so when j is equal to 1, it comes out of the block and it will check for the condition. Here c is equal to a of ij divided by a of ji jj. So this is a statement which takes the second row first element and divide it and stores in C. So it becomes 0. That elements become 0. After that, again the for loop is taken, because when we try to make that element 0, all other elements also changes. So keeping the value of C, what the thing is, like all other elements will get 0. So this is the statements which makes changes in all other elements and it come out of the loop. So this process is done until and unless the triangular elements get 0. So this is a statement which makes triangular element 0. After making triangular element 0, the next step is backward substitution, and here we can see a set of statements which is used for backward substitution. So this is a set of statements which is used for backward substitution, and we can see here the first statement, x of n is equal to a n into n plus 1 divided by a n into n. So here this is the statements which is used to find the value of z, as the lower equation, that is the third equation, we make it as row 1, row 2, row 3. So in row 3 equation, all the elements will be 0 except z. So that LHS will be equal to RHS. Taking that equation, we can find the value of z. So this statement is used to find the value of z and stored in x of n. And again we get inside the loop, for loop, and then we'll be finding the value of x. Before that, this is the statement which is used to find the value of y, and keeping this sum, we'll be finding the value of y. So value of x. So this is how we'll be finding the unknown variable x, y, z, and as we'll be printing three values, again it will take for loop, print the values, and the values are returned. So now let me run the program to find out the output. So I'll be clicking on build and run. So here it is asking for order of the matrix. Let me give it as 3, and the values is 1, 1, 4 and 12. So this is a values, that is the coefficient of matrix equation 1, and now I am entering the coefficient of equation 2, 8 minus 3, 2, 20, and next I am giving the coefficient of equation 3, 4, 11, minus 1 and 33. So these are the inputs I am giving. So this is a 3 into 4 matrix, where this 3 is the coefficients of LHS and this is the value of LHS. So I am giving this as row wise. So now let us see the output. So here you can see the solution is x1, x2, x3, where x1 is equal to 2.856423 and x2 is equal to 2.120907 and x3 is equal to 1.755668. So this is the value of x1, x2, x3. These three were the unknown variable. This is how we'll be running Gauss elimination method. Thank you.